Hello दोस्तों, welcome to our channel and today we will discuss loop how to put decision making inside a loop. Okay, so for that we are making a small program to find out that a number is a prime or not. Okay, and what are the examples from the prime numbers? Is it 2, 3, 5, 7, 11, 13, 17, 19, and so on. It means the number which is only divisible by itself. Okay, and it is more than 1, generally we say it. So, and otherwise, suppose any other number in like the rest of the number, like 4, 6, 8, 9, these are the composite numbers. Okay, so as the concept suggests, like suppose if I say number is suppose 5, so how we will start, like what will be our approach? So similar, as we do in the maths, what will be the formula, how we will start? So if I say number is 5, then straightforward, what I have to do, I have to check is that number is get divisible by any number from 2 to 1 less than 5, which is 4. Like, can I get like this? Like, what will be the remainder by 2? Okay, when I divide 5 by 3 and when I divide 5 by 4. So percentage symbol is used to get me the remainder. So here it will be 1, here it will be 2, and here it will be 1. So if a number which, let's say the number is n, and if it is not divisible from any number to 2 to n minus 1, it is a prime, and otherwise it is composite. Okay, that is the simplest definition we can give. So how we will start now? So here I'm just making it comment, so otherwise it will throw an error. So here I says int, then input is a function, then give a message like enter a number, and then if you noticed, here we are taking the n, and then we have to generate these numbers. So what will be the formula for generating these 2, 3, 4? So it is like for x in range is used to generate the sequence. What will be my start point? It is 2. And what will be the end point? It is n minus 1, including n minus 1. So obviously I have to put there n. So then it will generate me up to n minus 1. Let's print it first, and then move forward. So suppose if I give 5, will it generate 2, 3, and 4? That's good. Okay, now I have the x, so what will be the formula? I have to put, like, n will be there, so I have to put n percentage x, and it will be 0, that I want. Okay, but it will be inside a decision making. So if that number give me the, like, there is remainder is 0, it means that number is completely divisible by that particular value of x. So in that case, what I have to write? I have to write print, let's say, like composite. Okay, and otherwise what I have to write? It's a prime. So let's see what it will give you. So if I say 5, it says prime, prime, prime. Why? It gives you 3 times, because each time when we run this, so it checks this one. Yeah, it says it's not 0, so it's print a prime. Then it says 3. Okay, then it's get 2 here. It says again it's not equal to 0, so then it gives you like prime again, and then again prime. So in that case, what will happen here now? So here we are getting 3. Okay, so before that, let's see one more case. What will happen in case of if I give 6? It says composite prime, prime. So here it is issue. First issue is, when a number is composite, then I don't need to go any further. I have to stop there. Okay, so for stopping a loop at our choice, whenever we want, we have to put a break keyword actually, and in normal we say it is a statement. Okay, so break is a keyword. It takes you out of the loop wherever it is, like it put it here, So it take you out of this loop and it will be directly coming at this point. Let's see now for the same input 6 what it will give you. If I give 6 here, now it says composite. That's working fine with the non-prime numbers. Then now if suppose I gave it here 7, look at that what it says now, prime. So there is one more concept of keywords we have is a else. Okay, so whenever we want a loop to run completely, and how we will check, suppose here it is checking for 2. This one is for 7 mode 2, 7 mode 3, 7 mode 4, 7 mode 5, 7 mode 6. We are not getting 0. So in that case, like it's as per the logic, it says it is a prime. But how we will identify? So here it is. Nice option available in Python. You can put else in, like in addition with the for loop. So it's a, now what is the combination? It's for else. So when this block will execute, when this loop runs completely, it means it won't execute this part. Okay, so you can give any number. Look at that. Now if I give 7, what will happen? Look at that. If I give 7, it says it's a prime. Okay, so like, and what will happen in case of if I give suppose 6? Okay, so this one is okay, fine. Can anyone identify any issue? Like suppose if I let's run this one. Suppose if I give 1 0 0 0 0 1, it says it's a composite. Okay, if I give 1 0 0 0 1, it says it's a composite. Okay, if I give 1 0 1, it's a prime. Okay, so can anyone identify any issue, like what is the wrong with this code? Okay, let me give you a hint. It's related with the number of comparisons. So how we can reduce the number of like comparisons. Okay, so how we can reduce, like how many times this will run actually. So obviously we have to do something here. So drop me in the comments like how you will do it and up to which level you are able to get it up to. Like for 101 I have to compare it up to 99 times. Like for 7 I have to go for like 5, like 2 3 4 5 6, and for 5 I have to go for 3 comparisons. So similarly for 101 I have to go for 99s. So can we reduce this 99 to maybe 50, or maybe around, maybe you can go for like 10 or 12, or maybe around 15 or less than. Drop in the comments. Okay, thank you.